Okay, so this is similar in the sense that the context is similar. Also, in this case, cooperation is with Grundfos, and the interest, which raised also after a presentation of the possibility, is to focus on tracing evidence in relation to these different dimensions that I mentioned before. So, trace evidence for continuous quality product process assurance justification. Okay. And in this case, we talk about pumps. Grundfos is producing pumps, different types of pumps. We have not looked into the changes in this case. We started reasoning on how to trace the different work products. And for me, since I'm new to pumps, was also an initial understanding of what a pump is. General idea, yes, but understanding a little bit more what a pump is and which are the regulations and the standards that apply in that domain. So also this one is highly regulated. Also, in this case, of course, there are departments that within Grundfos and, of course, within companies that develop pumps in other places for interest for cybersecurity. We have not looked into that yet. I'm progressing in my knowledge. And so I looked into we looked into standards that are domain independent, like 1200 for risk assessment and control, so risk management. We looked into domain specific standards, so for pumps. We looked into regulation, the machine directive, and so the notion of harmonized standards that are endorsed by the regulations as standards that support the compliance. And specifically, this is among the harmonized standards for pumps, specifically in order to comply with the machine directive. Also, at Grundfos, there is an interest for continuous delivery and also specifically in responding to failures quickly, developing trust, and introduce changes if this is needed, and continue. The way of working from a standard perspective is also that you have a machinery definition, then you have a safety risk assessment. And here also there is an interest, since we have focused the attention on the hazards, the risk assessment, when we have identified the risk, and we do have also the portion for the control, so we know which are the measures that we want to take in order to control the risk, then we could think that eventually, when everything is in place, we could present a kind of drawing that is showing, justifying the fact that all the hazards are avoided. Okay, so this is a pattern that is quite famous in the argumentation community in safety, but this is just the cherry in the way you could present once the hard work of conducting a very good hazards analysis is there, and implementing the most of the measures within the design and understanding what remains outside, what will be delivered as procedures for the users in order to decrease even further the risk. So motivation here is that if you want to show compliance, you need to have traceability in place and understanding how to trace the risk design in order later on to automate the justification. Work that have been done previously is related to OSLC, Open Service for Lifecycle Collaboration. I had a collaboration with Scania. I had a mobility project there, and we worked on a kind of vision to have possibility to have Spark query, having a graph DB where you have your ontologies, and you can query the ontologies in order to understand if you have all the pieces, so the hazards, the goals, the safety goals, functional safety requirements, technical safety requirements, hardware safety requirements, software safety requirements, test obviously attached to it in order to trace that, yes, I have an hazardous event and I do have the complete chain in order to show that there is something inside my system that is taking the responsibility for that hazardous event. So this was the vision. So since Grundfos attended a presentation, they developed interest, and the reason is that they developed interest because currently they are working Excel-based using templates. They are working within SharePoint, and the interest is understanding how to move further. There was also a work in another department in order to, in the context of the software center, in order to develop a traceability information model. But at the start of this project, since we needed to focus, there was a decision internal at Grundfos to discard that for this specific project. There are different departments, and I'm cooperating with the compliance and quality department. So the long-term goal would be provision of a methodological and ontology-based framework for tool interoperability and evidence traceability for continuous justification. So it could also be that you discard OSSC, but you remain with the semantic web. Recently, I have seen that, for example, there is a good connection with respect to some tooling. I could not explore that much the tooling due to some security policies, but what I could explore was that there is a link between the SharePoint and the semantic web. So working in SharePoint is not necessarily negative if the company is small sized. And we are creating the case around, we're starting with the pump. And then in future, the two projects could converge because we might be interested in the variability as well. But at the moment, we are connecting the different pieces. Work done. We have selected a type of pump, centrifugal pumps, considering drinking water. We have focused on the safety risk assessment and control. We have looked also, we have scoped even further. We have considered a subset of possible hazard types. We have considered thermal hazard types and electrical hazard types. And the reason is this, that I have shown to you one standard before, the general one for risk assessment. But as soon as you are interested in specific hazard types, you open the door for other standards. So you have standards for risk assessment for the thermal hazard type. And this is interesting because at this point, I have been working on trying to think, so I present this first, trying to think about a possible way just to understand and communicate, possible way to visualize the process for risk assessment and control that takes into consideration this, that initially you follow the process that is within the domain independent and generic hazard type, and then if a specific standard exists for that category, then you zoom into that specific standard, and this is a general thing. It's not. This is not about pumps. This is a general thing. The thermal standard, not only for pumps. And what again I was doing was to extract the features from a compliance perspective from the machine directive. So what is required at risk assessment for a risk assessment procedure, and then understand what is present at Grundfos. Okay, so such that we have created the traces for the specific clauses within the machine directive, and also looking into, okay, the connection between the machine directive, the domain-specific standard, the harmonized standard for pumps that replies to that machine directive, and Grundfos. So we have this traceability in place. We worked on process side, waiting for having the artifacts for what? If you look into the standard for risk assessment and control, you can see that there they have a schematic representation for a machinery. So the idea would be that we have the process at abstract domain independent level. We do have the product, the schematic representation of a machinery at domain independent level. And then we have the specialization for the domain specific pumps, that could be another domain that is specializing the machinery. And we do have the process that is domain specific, but could be specialized, configured for a different domain. So this is mainly what I managed to do in cooperation with Grundfos. So initial traceability related results, risk assessment and control process. Next, also in this case, reiterate, during this sprint, I was not able to write a paper because I was learning a lot of things which were new to me. Incorporate the increments, and also in this case, we are interested in creating the ontology. If you have a question, or if you are interested in the machine directive and you want to know more, I'm here.